back to today's tutorial. Today we will be learning about delta to y and y to delta transformation. For some circuits, example is the bridge network. It's not possible or it's not easy to combine the resistors in series nor parallel. So for those kind of circuits, we apply the three-terminal equivalent network. That is the delta or pi and what? Y or T. So we have a delta network or what? The pi network. So this is how the delta or pi networks look like. The delta looks like this. It's a three-terminal, so it has 3 branches, and on each branch we have a resistor. This is the delta shape. So let's name the resistors on what? The branches. Let's call this point, let's say point A, point B, and what? Point C. So I'm going to name this resistor values here. Let's say this resistor is between point A and point B. So I want to name it resistor RAB. This resistor is between A and C. So what? RAC. This one is between B and C. So I have resistor RBC. So what we are saying is that this delta is also known as what? A pi network. So we know from mathematics our pi looks like this, the shape of a pi. So when I take this branch here and I straighten the branch here, the wire, I also take this branch here and I straighten. It looks like what? A pi. So the delta is also what? A pi network, and this is how the pi looks like. So we can name this as a single what node. So this resistor RAC is the same as what? The resistor. Yes, so let's say RAC. RAB is the same as what? The RAB here. And RBC is what? The resistor here. So what we can do is we are going to change a delta network to its equivalent network, which is what? The Y network. And as I said, the Y is also known as what? A T. So a Y network looks like this. A Y. It looks like our capital Y, our alphabet where we have. It's also a three-terminal network, so 3 branches, and on each branch we have what? A resistor. So this is the Y. And the Y is also known as the T. What I mean is, if I take this branch here and I straighten it, I put it down like this. And I also take this branch and I straighten it like this. It looks like what? The capital letter T. Good. So this is what? A Y network or a T network. So I have a T and what? A Y. This is what? A delta or pi. So in this conversion, we are going to change from a delta network to its equivalent network, which is a Y. Now the question is, how do we do that transformation? It's just mathematics, formula work. You just have to know how to convert a delta value to its equivalent Y. So let's see how to do that. So we will convert this delta shape here. Let's say we have this delta. Let's consider the delta. And I want to change this delta to its what? Equivalent network Y. What we have to do is, let's try and trace the Y from the delta. This is the delta. Let's trace the Y. So what we do is we look at this point here. We are drawing the Y in this. So the Y looks like this. We have one of the branch here. We have another one here, and we have the long byway here. So that's the Y inside the delta. So let's take that Y out. We have it here. Good. Good. So this Y, let's see, let's put resistor 1 here, another resistor here, another resistor here. So this is the Y that I have placed there. So from delta to Y. So let's name the point. Remember I said this point, let's call it A, right? So that Y, we have what? Our A here. This point is the B. Let's call this point what? The C. Now I'm going to label or name these resistor values. This resistor here, I'm saying it is connected to node A. So I'll call it RA. You can call it, and someone can say R1, R2, R3 is the same thing. I'm calling this one the y value RB because it is connected here. We have RB. Then I'll call this one what? RC. Alright, so now our job is to what? Calculate the values of RA, RB, and what? RC from the delta values RAB, RAC, and RBC. How do we do that? So let's see. If you want to convert, it's a formula work. Let's see how best we can memorize the formula. If you want to calculate the y value RA, you can do this. Check your delta values where you drew your y. This value is connected between two what delta values. It is lying between what two delta values, and the values are RAB and what RAC. So what we are going to do is we are going to multiply those two delta values. So if I want RA is what the multiplication of RAB and RAC. So I have RAB multiplied by what? RAC. And I'm going to divide it by what? The summation of the delta values. And the values are RAB plus RAC plus RBC. That's how you can calculate for what? RA. The same thing applies to the other two Y network values. That is RB. So as your RB is lying between which two delta values? RAB and what? RBC. So let's multiply them. RAB times R what? BC over what? The summation of the delta values. RAB plus RAC plus RBC. That's how you calculate for your RB. So the last value left is what? RC. And to get RC, this is our RC, and it is between RAC and what? RBC. So our RC is what? RAC multiplying RBC over summation of the delta values. RAB plus RAC plus RBC. So now we've managed to get the Y network values from what? The delta. So what you have to know in this formula is that your denominator will be the same for all the three Y values. Your denominator is the same. It is your numerator which what? Changes. Okay, so this is the formula to convert from a delta to a Y, or a pi network to a T network. So let's take a simple network on its own, a delta network on its own, and let's see how we can get the what? Y network. This is an interesting concept, very simple to understand. Just follow the procedure. So let's say we are going to convert a delta network towards a Y. So I have this delta network here. Let's say this. Let's give it any value. Let's say this is 10 ohms. Let's call this one 5 ohms and what? 3 ohms. So you are given this and you have to find the Y network equivalent of this. So they want you to find the Y values, all the three, not just one, all the three. Alright. So in doing so, this shape is in what form? The pi. But as I said, the pi is the same as what? The delta. So let's draw our Y in this one. So our Y in this one, let's say we have this junction here, this junction, so we can draw our Y. So our Y looks like this. That's our Y. So I have this one here. I have this branch also here. Then I have this one here. So let's name the junction. Let's say A, B, and what? C. So our Y values, we have RA, RB, and what? RC. So we are going to use the formula to calculate for RA, RB, and what? RC. It's very simple. You don't need to memorize the formula. Just know how to derive it whenever you are asked. So as we learned earlier, to calculate RA, let's check the delta network. RA is here, the Y value here. This is RB, this is what? RC. So RA is lying between 10 and 5. So we multiply those two values. So 10 by 5 over what? The summation of the delta values, which is 10 plus 5 plus 3. And this gives us what? This is 50 on what? 18 ohms. I'll leave it like this. I don't need to simplify further. So 50 on what? 18 ohms. The next value is, let's say, RB. How do we calculate RB? This is RB here. So RB, RA, RC. So RB is lying between 10 and 3. I have 10 by 3 over what? The summation, which is the same as this one. So I have 30 on 18 what? Ohms. That's RB. And the last Y network value is what? RC. And this is RC. 5 by 3. So we have 5 by 3 over 10 plus 5 plus what? 3. Giving us 15 on 18 ohms. So these are the Y network values, all the 3. So you just have to draw this and place where your value should be appropriately. Please make sure you place your RA here, your RB here, and what? Your RC here. Don't interchange them. So this is how to transform from a delta to a Y. We are now going to do from what? A Y to a delta. That one too is a formula work. So let's see how to convert from a Y network to its equivalent network, which is the delta. Good. So let's draw our Y network. Now we have the Y. So let's say this is A, B, and what? C. So let's call this one, let's say RA because it's connected to A, RB, and what? RC. They can give you the shape in the form of T, but don't forget you can draw it in the form of Y because they are the same thing. So now we are changing the Y to what? A delta. So what we can also do is let's draw the delta around what? The Y. When we're doing the delta to Y, we drew the Y inside the delta. Now we are doing Y to delta. So let's draw the delta shape around what? Our Y. So delta looks like this. Our one branch is here, another branch is here, another what? Branch. So let me take off the Y. Then the delta looks like this. I have this one there. I have this one there. So one of the resistor is here, another one is here, and what? Another one is here. So let's name the resistor values. This resistor, the delta resistor, is between A and what? B. So I can name it RAB. This one I can name it RAC. This one can be R what? BC. So let's bring the values. This is the RAB, AB, and what? C. This is RAC, and this is RBC. So now let's see how we can convert from the Y when we have the Y values to what? Delta. So if I want to find RAB, this value here, RAB, how will we do it? And in doing this one, you can also use this idea. We are going to multiply the Y values 2, take 2 of them, multiply, and add it to what? Another multiplication of 2 of the Y values. Take time. Take the RA, multiply by what? The RB. So we have RA multiplied by what? RB plus, let's take the RA multiplied by what? The RC. So we have RA multiplied by RC. Now it's left with it's left with RB and what? RC. So we take the RB and multiply by what? RC. So you see that each of the Y values is appearing twice in the multiplication. RA is appearing twice, RB is appearing twice, and RC is also appearing twice. And we divide it by what? Let's see. You can see that this RA and this RB are what? Surrounding your RAB. Now we are going to divide it by the value which is far opposite from what? Our RAB. So among these 3, which value is far away from the RAB? It is our RC. So we are dividing this by what? RC. Then we move on to the next delta value. Let's say RAC. And in this case too, the fun thing is the numerator is going to be what? The same. The numerator is going to be the same. So just copy your numerator RA, RB, RC, RB, RC. Then you divide by what? Let's check. This is what? RAC. And it is surrounded by which two y values? RA and what? RC. So it is the RB which is far away from what? RAC. So you divide it by RB. Then you take the last delta which is what? BC. So the numerator is the same. RA, RB plus RA, RC plus RB, RC. Then we divide by what? This is RBC. This and this are surrounding this one. So divide by what? RA. Good. So this is the formula helping us to convert a y to what? A delta. You can see if I want RAB, I'm dividing by the other point which is what? C. RAB, so I'm dividing by RC. If I need RAC, I'm dividing by what? RB. If I need RBC, I'm dividing by what? RA. So you can use that one to also derive your equation. You need not to what? Memorize this formula. So now let's take one example and see how you can convert the y to what? The delta. So let's take a y network on its own. Let's see a y network is given like this. This is the y what? Network. Let's give it some value. Let's say 10, 20, and 40, right? Say 10, 20, and 40. And we are asked to find the delta equivalent of this y network. We are asked to find its delta equivalent. So if you are not used to the t, you can just draw the y version of this, which looks like this one. Which looks like this. If you are not okay with the t, just draw it in y. We have our 10 here. You have your 20. You have what? Your 40. You can work with this one because they are the same thing. Now you draw your delta around what? Around your y. You draw your delta neatly. Just use some broken lines to draw your delta. Now let's take our delta here. So it looks like this. It looks like this. So this, let's name it. Let's see. This is A, B, and what? C. So this becomes A, B, C. So I have resistor RAB. This delta value here. I have this one to be AC. So RAC. I have this one to be BC. So RBC. So now let's use the formula to calculate RAB. So if you remember what we said, we are going to multiply what? The y values in pairs. So we take what? This one multiplied by this one. So let's go straight forward. 10 by 20 plus 10 by what? 40 plus 20. 20 by what? 40. Then we divide it by what? We want RAB here. So this and this are surrounding this one. So we divide it by the other value, which is what? 40. Now we are to punch this on our calculator. So we have 10 by 20 plus 10 by 40 plus 20 by 40 divided by what? 40. And we are getting 35 what? 35 ohms as our RAB. So our next value is RBC. And if you remember, we said the numerator is the same. The numerator is the same. So we can get the numerator. The numerator is giving us 1,400. The numerator here. So we are going to divide it by what? RBC. This is the RBC. This one. So we are going to divide it by the value here, which is 10. So this is giving us what? 140 ohms. Then we move on and calculate for the last value, which is RAC. So RAC. So we still have what? 1400, and we are going to divide it, this value, by what? By 20, because these two are surrounding this one. So you divide it by the 20, and what do we have? We have what? 70 ohms. So these values are what? The delta equivalent of what? This Y network. So in our videos to be uploaded later, we will be using a complete circuit to calculate what the current in a given what resistor, using circuit which has a delta shape or the Y shape. Thank you very much for watching this video.